Fibonacci spaces. If T is a continuous linear transformation, if T is a continuous linear LT means linear transformation. Continuous linear transformation. B onto B dash. B onto B dash. Needle perpendicular B onto B dash. Itlanti black B onto B dash. B onto B dash. Then the image of each open sphere SR, the image of each open sphere each open sphere ఇట్లా మీరు కింద చూడు పెద్దమ్మా each sphere SR dash in B dash SR dash in SR dash in B dash. Proof. Yeah, proof. No. Now show that for each R is greater than 0. We need to show that. We need to show that. We need to show that. To show that. R is greater than 0, then they exist. Small r is empty. Then there exists. Then there exists. S is greater than 0. S is greater than 0. Such that SR dash subset are equal to SR dash subset are equal to TSR TSR TSR. First, we observe the TSR. First, we observe that. P of SR. P of SR. P of SR. Equal to PR plus 1. R plus 1. R plus 1. Plus 1. That equal to R P of S1. R P of S1. So since T is onto, it follows that. Since T is onto, T is onto. Since T is onto, since T is onto, it follows that beta dash equal to 1. It follows that. It follows that beta dash equal. It follows the beta dash. Follows the union I equal to 1 to n. P of S1. Union equal to I equal to 1 to n. 1 to n. Union S equal to 1 to n. P of Sn. P of Sn. P of Sn. P of Sn. So beta dash is Banach space by Berry's theorem. Beta dash is Banach space. Banach space. Beta dash is Banach space. Beta dash is Banach space by Berry's theorem. Berry's theorem. By Berry's theorem. There exists at least one set. There exists at least one set. There exists one set. There exists one set. S, there exists one set. S and not such that. S and not such that. Such that. P of S and not. P of S and not. P of S and not. Contains at least one interior point. Contains at least one interior point. One interior point. PT means point. Interior point. Why not belongs to Sn? P of Sn. Why not belongs to P of Sn? P P of Sn. Since the mapping y tends to y minus y1, y tends to y minus y1 is a homomorphism of B dash onto itself. Is a homomorphism. Is a homomorphism of B dash onto itself. B dash onto itself. Onto itself. It follows that 0 is an interior point of. It follows that 0 is the interior point. Is the interior point of Tsn naught minus y naught. Tsn naught minus y naught. Minus y naught. It is easy to see that B dash is easy to see that Tsn naught minus y naught subset are equal to Tsn. Is easy to Tsn minus y naught subset are equal to P of S to N. From this, we conclude that since y tends to y tends to a of ay. Now, a scalar is a homomorphism of B dash. A is a scalar. Scalar is a homomorphism. Homomorphism of B dash onto itself. Of B dash onto itself. Onto itself. 0 is an interior point of PS1. 0 is an interior point. Onto itself. PS1 bar. So there exists an open sphere. There exists an open sphere. SR dash such that S epsilon dash subset are equal to S epsilon dash subset are equal to PS1 bar. P of S1 bar. We now conclude proof by showing that S epsilon dash subset are equal to PS1. So let y belongs to B dash. Y belongs to B dash such that norm of y less than epsilon. Is less than epsilon. Since y belongs to S epsilon dash, that implies y belongs to S epsilon dash is subset are equal to T_S1, T of S1 bar, 1 bar. It follows that there exists X1 such that norm of X1 less than or equal to norm of X less than 1, and norm of Y minus Y1 less than epsilon by 2, norm of X minus X1 less than epsilon by 2, where Y1 belongs to T of X1, where Y1 belongs to T of X1, T of X1. Observe that S epsilon by 2 is subset or equal to T of S half, T of S1 by 2, S1 by 2. By the same argument as above, we find by the same argument, by the same argument, above we find X2 belongs to B. We find X2 belongs to B. X2 belongs to B. So that norm X2. Norm X2. Yeah, norm X2 less than half. Norm X2 less than half. And norm of Y minus Y1. Norm of Y minus Y1. Y minus Y1. Minus Y2. Less than epsilon by 4. Where Y2 equal to T of X2. Where Y2 equal to T of X2. T of X2. Continuing in this way, we obtain the sequence. Continue. This process. Continuing this process, we obtain continuing this process, we obtain sequence of xn, sequence of xn in B such that norm of xn less than 1 by 2 to the power of n minus 1 and 2 to the power of n. Norm of y minus y1 plus y2 plus y1 plus y2 plus yn less than epsilon by 2 to the power of n. 1 by 2 to the power of n. Epsilon by 2 to the power of n. Where yn equal to p of xn, where yn equal to p of xn, p of x. Sn equal to let Sn equal to x1 plus x2 plus so on xn. Then it is easy to see that Sn is a Cauchy sequence in B dash. It is easy to see that. Sn is a Cauchy sequence in B. Sn is a Cauchy sequence in B. Further, Cauchy sequence in B. Further, norm Sn. Further, norm of Sn less than or equal to 1 to n xi less than 2 sigma 1 to n norm xi less than 2. B is being complete, it follows that B is being complete. It follows that there exists here. It follows that there exists here. In B such that Sn tends to x. So norm. So norm of x equal to limit Sn equal to norm limit Sn, norm limit Sn less than that equal to limit ultimate limit norm Sn less than or equal to limit less than or equal to Sn equal to what we defined before, x1 plus x2 plus so on xn. No? That is, so this we write it as limit norm x1 plus norm x2 plus so on norm xn, norm xn is less than or equal to limit 1 plus 1 by 2 plus so on plus 1 by 2 to the power of n minus 1 is less than or equal to 2, which is less than 3. So this shows that x belongs to S3. This shows that x belongs to S3. Finally, T is continuous. We have finally T is continuous. We have T of x equal T of x. T of x equal limit Sn. T of limit Sn. Limit Sn that equal to limit T of Sn. That equal to limit T of Sn means what we defined, x1 plus x2 plus so on xn we defined. That equal to limit y1 plus y2 plus so on plus yn. So y equal to T of x. That means y equal to T of x. Y equal to T of x. That belongs to T of S1. That belongs to T of S1. So y is arbitrary. It follows that y is arbitrary. Y is arbitrary. It follows that. S epsilon dash subset are equal to TS1, TS3. So consequently, S dash epsilon by 3 is subset are equal to T of S1. From thus, it follows that given R is greater than 0, there exists S equal to R epsilon by 3, epsilon by greater than 0 such that yes, S epsilon dash subset are equal to T of S R P of SR. This completes the proof. Hence theorem. Hence the theorem. So lemma we prove. Next. So open mapping 4.4.2. 4.4.2. The open mapping theorem. The open mapping. Open mapping theorem. Open mapping. Open mapping. Statement. If B and B dash are two Banach spaces, B and B dash are two Banach spaces, Banach spaces, and T is a continuous linear transformation, and T is a CTS. CTS means continuous, LT means linear transformations, LTS means linear transformations of B onto B dash, of B onto B dash, B onto B dash. Then T is a open mapping. Then T is a open mapping. T is a open mapping. Proof. Proof. To show that T of G is open in B dash, we need to show that. We need to show that T is a T of G is a open mapping. Open mapping. Open mapping. Open in B dash. In B dash. Whenever G is open in B, whenever G is open in B, open in B. That is to prove that every P of G is an interior point of P of G. P of G is an interior point of P of G. So that every point of P of G is an interior point. Let Y belongs to P of G. Here. Then the resistance small x belongs to G. Such that Y equal to P of X. That Y equal to P of X. Y equal to P of X. X belongs to G. G is open, there exists here. X belongs to G. X belongs to G. G is open. G is open. G is open. So there exists open sphere. Open sphere. There exists no control. Yes, XR. What is the meaning of XR? X is the center or with the radius such that. Yes, XR. XR is subset or equal to G. Since SXR XR equal to X plus SR. It follows that Y plus P of SR that equal to P of X plus T of SR that equal to P of X plus SR. subset are equal to T of G. Subset are equal to T of G. That is y plus s yx dash x dash subset are equal to y of y plus T of SR subset are equal to T of G. Subset are equal to T of G. So S dash y of S S dash subset are equal to T of G. Subset are equal to T of G. Subset are. This shows that interior point of T. Y being arbitrary, it follows that Y being arbitrary. It follows that T of G is open. T of G is open. This completes the proof of the theorem. Hence the theorem. Okay, now we proved open mapping theorem. Next, most important theorem is 4.5. Homework. Most important theorems. Most important theorems. Most important theorem. Closed graph theorem. That means 4.5.1. Closed graph theorem. Closed graph theorem. Next, uniform bounded theorem. Uniform bounded theorem. Okay, 4.6.1. 4.6.1. The uniform bounded theorem. The uniform bounded BDD means bounded theorem. Uniform bounded theorems. Uniform bounded theorems. So this theorem are good as most important. So shall we have time limited? That's why we proved for open mapping theorem. Lemma and these two. So thank you very much. Now leave the meeting.